Okay, starts mechanics year 1, question 11, chapter 11, question 10. Particle P moves along the x-axis, passes through the origin at t0 with a speed 7 meters a second. So we have point 0, that's t equals 0, and it is doing 7 meters a second at that point. Okay, in the direction of x increasing. Excellent, so it's coming across here in a positive way. Right, at time t seconds, the acceleration of p in the direction of x increasing is 20 minus 6t. So acceleration is equal to 20 minus 6. What's that? 6t meters a second minus 2. All right. A, show the velocity v of p at time t seconds is given by, they want to see that the velocity is equal to 7 plus 20t minus 3t squared. Well, since velocity is equal to the integral of the integral of acceleration in terms of time, then velocity is equal to the integral of 20 minus 6t dt. So let's increase the powers and divide by the new ones. Okay, so we've got 20 over 1t minus 6 over 2t squared plus c. Okay, is your velocity, and of course we were told that we had a velocity of 7 meters a second. Okay, so velocity equal to 20t minus 3t squared plus c, and we know it's 7 when we have got a time of 0, so putting in that 0 we get the fact that c equals 7. Substituting it all in, okay, means that we get velocity, these are 7s by the way, velocity equals the 20t minus 3t squared plus 7, which is the same as up there except for written in a different order. Good. Part B, okay, show that the velocity equals 0 when t equals 7. Okay, so if we do velocity is equal to 20 times 7 minus 3 times 7 squared plus 7. Okay, just substituting in the values. We can see that v equals 140 minus, what's that? 49 times 3 minus 147 plus 7, so v equals 0. Okay, so there you are, that's that bit done. And it says find the greatest speed of p. So if that's the velocity, the greatest speed, well, for a start it's a quadratic, isn't it? So it's going like that. So if we differentiate it, it will be when the acceleration hits 0. So if we were to do the integration on this formula, we'd be able to find not the integration, differentiation on this formula. It brings us back to 20 minus 6t. So if we set acceleration equals to 0, 0 equals, what was it? 20 minus 6t. Okay, we get minus 20 over 6, or minus 6 t, which is of course 10 over 3. And what were we looking for here? We were looking for the greatest velocity. Okay, so that's like 3.3. So if we put it into the velocity equation now, 10 over 3, what was it? Here it is. Velocity equals 20, 10 over 3 minus 3, 10 over 3 squared plus 7. We should get, what's that, 200 over 3 minus, square that one, multiply it by 3, 100 over 3 plus 7. That gives us 121 over 3, which is 40 and a third meters a second minus 1 for the greatest velocity. Okay, find the distance travelled by p in the interval of 0 to 7. So since we've got the velocity equation, we can find the distance equation, because distance is equal to the differentiation of the velocity, which, since we know it up here, where is it? It's that one, 20t minus 3t squared plus 7. When we come to differentiate that, no, not differentiate it at all, my apologies. When we come to integrate it, that will be the integration of the velocity, okay, with respect to time, and so that will become 20t squared over 2 minus 3t cubed over 3 plus 7 over 1t plus c. And so your s becomes 10t squared minus t cubed plus 7t plus c. Now we know from the beginning of it that we are at 0. We have travelled 0 distance at time 0. So substituting 0 in here with the distance of 0, we see that the c component of this disappears. So s equals 10t squared minus t cubed plus 7t. There's the formula for that. Find the distance travelled in the interval of 0 to 7. Okay. Well, we know it's travelled 0 there, and if we put it in as 7, we get 10t 7 squared minus 7 cubed plus 7 times 7. Okay, and that gives us a distance of 49,490. 7 cubed is 343 plus 49. Okay, 490, take away that one, add 49, gives us a distance of 196 meters. But is it? We had a non-constant acceleration. We had a velocity that was, did we ever have a negative velocity in that time? Okay, I don't think so. It just got down to a velocity of 0, didn't it, at a certain point. So I think all good. So yeah, checking the answers, that's all good. 196 meters a second. Okay, you've just got to watch out for when you end up with negative velocities included in it. Okay, but I think we're all good. Right, next one.